Today's session is on fiber optics. So, fiber optics is the science of transmitting data, voice, and images by the passage of light through thin transparent fibers. So, we are all familiar about optical fibers. So, these optical fibers are used for communication purpose. So, in communication, our voice data is transferred through these optical fibers. So here we are discussing about the structure of optical fiber. So this center portion is called core, and this core is covered with an outer covering. This is called cladding. So this cladding acts as a protective medium for this core. Then this cladding is covered with another coating that is called coating itself. Then this coating is covered with another strengthening material that is represented by using this green color. Then these four arrangements are covered by outer jacket. So when we observe an optical fiber, we see this outer jacket. So light is transmitted through this core, and this core is a dielectric material, and this cladding also another dielectric material. So light is transmitted through this core. So the center portion is called core and the outer covering is called cladding. These two are important. Then this core and cladding are protected by three layers of covering, that is coating, then strengthening material, strengthening covering, then the outer jacket. Then the core. Core is the central portion of the optical fiber. So light is propagated through this core. So here we use transparent dielectric material for the preparation of this core. And this core is covered by another dielectric material. It is called cladding. So another dielectric material is used for the preparation of cladding. Then here the refractive index of this material, it is represented by N1, and the refractive index of core is always greater than the refractive index of cladding. That means here the working principle of optical fiber is total internal reflection. So total internal reflection, we can simply say that when light enters into this core, it totally reflected back to the same medium from this core cladding interface. This is the working principle of optical fiber. So for this process, the refractive index of core must be greater than the refractive index of cladding. So this is the structure of optical fiber. Specific structure of optical fiber. Center portion is called core and its refractive index is always greater than the refractive index of cladding. This core is covered by a protective layer. That protective layer is termed as cladding. The refractive index of cladding is always less than the refractive index of core. The working principle of optical fiber is total internal reflection. Then we goes to the total internal reflection. So here in this first diagram, this is the incident ray. So when a light ray enters from one medium to another medium, at this medium interface, it get reflected. So here this angle is the angle of incidence and this angle is the angle of refraction. So this is the incident ray and this ray is the refracted ray. So here this is angle of incidence and this is angle of refraction. This is normal refraction. Then we go to the second diagram. So in the second diagram, here this is the incident ray, and the light ray is refracted through this interface, that is the angle of refraction is 90 degree. This angle is 90 degree. So here this is called critical angle. So this is the definition of critical angle. So critical angle is the angle of incidence at which this angle of refraction is 90 degree. Angle of refraction is 90 degree means angle of refraction is maximum. That is called critical angle. So critical angle is the particular angle of incidence, this angle of incidence at which angle of refraction is maximum. This is called angle of refraction is maximum. This is called critical angle. So that is the definition for critical angle. That is the particular angle of incidence at which angle of refraction is maximum. That is the critical angle. Then in the third diagram, here the angle of incidence is greater than, this is angle of incidence, and this angle of incidence is greater than the critical angle. That means here the angle of incidence is, if it is theta, here the value is greater than theta. So in this case the light ray reflected back to the same medium. This is called a total internal reflection. So the condition for total internal reflection is, from this two diagram, this angle of incidence is greater than the critical angle. So if the light ray enters in critical angle, the light ray is refracted through or reflected through the medium interface. This is the first medium, this is the second medium. So here the light ray is reflected through the medium interface. That is, the angle of refraction is 90 degree. But in this third diagram, see this. This is the angle of this is the incident ray. So here the angle of incidence I is greater than IC. This is, here the condition is like this, angle of incidence is greater than critical angle. So angle of incidence is greater than critical angle, light is reflected through the medium itself. That is called, this is called a total internal reflection. Total internal reflection. That is the condition for, that is the working principle of optical fiber. So total internal reflection is when a ray of light travels from a denser to a rarer medium such that the angle of incidence is greater than the critical angle, the ray reflected back to the same medium. This phenomenon is called a total internal reflection. Simply we can say that if the angle of incidence is greater than critical angle, the light ray reflected back to the medium itself. That is called a total internal reflection that we observed in the diagram.